You're not going to want to miss this episode of the AI Show where we talk all about using R with Azure Machine Learning with my friend Mark. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about using R with Azure Machine Learning with my friend Mark. Mark, hello, my friend. Tell us who you are and what you do.
Hi, my name is Marck Vaisman. I'm at Microsoft,
Mhm.
and I have been at Microsoft for about 5.5 years. I'm a cloud architect, and I work with customers in the financial services. But in the last 6 months, or actually from July to December, I actually work with Seth and other folks on the Azure Machine Learning product team, which was a phenomenal experience.
Yeah, it's good stuff. So we're talking about R. I feel like there's something that we need to say about this.
Yes. What's a pirate's favorite language?
Was I was I too early on that? No, I think obviously this is the pirate's most favorite language. I wanted to get 2 rim shots in there. But the one question I get often is, can Azure ML do R? And I want to pose that question to you. Can Azure ML do R?
Of course.
Yeah,
Yeah.
but my sense is but what kind of support does it have? Can you give us a little bit more details on that?
Of course. So, we Azure Machine, like a lot of our philosophy is really to be open and open source. And Azure Machine Learning has evolved. And with the creation of the new CLI and the SDK v2, it's actually much easier now to use other languages than Python, which is where everything else was built on. So,
Okay.
having said that, what I want to show you today is really how to use R on Azure Machine Learning to do all sorts of things. I'm going to walk through an example of setting up your compute instance to use R in an interactive environment. Why do we want to show that first? Because typically the first step in your machine learning workflow or in your data science workflow is exploring your data. And that's actually an interactive process. It's really hard. Yes, you can write a job that
Yeah.
does that for you, but when you're first learning how to use a data set, you're trying to figure out what it is. You do a lot of interactive exploration, which includes slicing, dicing, joining. The 80% of time that
Yes.
gets spent on machine learning and data science work, right, which is the data wrangling and the data munging. A lot of that, the first time you do something is going to be interactive, right?
Yeah,
And then,
just like Python, right? We
yeah,
usually use notebooks to start, and then we got to move it into a job. So this is similar to the Python thing, but in R, use R interactive. Am I getting this right?
yeah. So, I mean, there's many ways to use R interactively. Obviously, the R has a console in a built in and of itself. There's a lot of there's IDEs. We have Visual Studio Code, which is what I'm going to show today. A lot of folks use R Studio, which is a great tool as well. So what I'm going to show you today is really how to, using VS Code, essentially you're working on your local machine, but you're connected to a remote instance and be able to do some of that exploratory work. So I'll start with that. And then I'm going to walk through an end-to-end example. Now, the other thing that I did want to mention is that, we love R, we support R. And recently we just published a whole new set of documents that are going to walk exactly through what I'm walking through today.
Cool. So I'm putting up below so people can go to that. I feel like I want to dive in and take a look at this.
Okay, so first of all, right, the first thing I wanted to talk about, obviously, my I'm hoping that you already have some experience around Azure Machine Learning. You understand, you've gone into it, you sort of understand all the bits and pieces. I don't have enough time to explain Azure Machine Learning as a whole.
Sure.
But what I wanted to show you is this. So typically, right, in the past, if you look at the documentation suggests to use a Jupyter notebook running an R kernel. I'm going to take it a step. I'm going to take it a step further today, which is really using, what the thing with Jupyter notebooks, it's sometimes it's not that friendly to be. You have to create a cell and then run another cell and then that sort of thing. I'm going to show you how to do an interactive R session on Azure Machine Learning. First of all, using VS Code. Now, why is this important? Well, because it could be that your data sets are already stored, or not stored, they're already linked to from your Azure Machine Learning workspace.
Right.
So obviously what I'm going to show you today, I have a sample data set that is in a repo. And what I'm going to do is show you how I created a data asset. And again, why the interactive work is important is because a lot of times your data is already on Azure. It's already either in Azure Blob or in Azure Data Lake, or maybe it's in SQL. And you want to be able to read that data interactively. So that's like step number one in the process. So to do that, right, the first thing you need to do, obviously, is you're going to create a compute instance. Now, as you can already see, I have two instances already running. The first instance is this one that I created earlier. It's called AI Show Demo. And then this is one I called AI Show New CI. Now, in the spirit of doing the the cooking show type exercise, I'm going to show you a little bit of how the turkey is made and then how the turkey comes out of the oven.
That's awesome.
Yeah. So the thing is, to actually use VS Code with R, you have to do a little bit of prep work. So there is a repo, right? I have this repo, and I don't know, Seth, if you can link to it. Like, I'm just showing the screenshot here.
Here you go. Yeah, this is the repo right here. I'm putting it right below.
Perfect. So in this repo, what I've already done is I started a compute instance, right? So I'm going to go to this compute instance, which is a brand new one. And sorry, this wrong screen. And what I'm going to do is I'm first going to go to I'm going to go to notebooks. Here we go. So what happens is this repo is already cloned into the workspace. But if you're doing this the first time, what you need to do is you're going to create a compute instance first, right, which is already here. Then you're going to go to notebooks. You're going to open a terminal, okay, and you're going to select. I'm going to select the new machine, right, which is this one. Make sure AI show new. And then what I'm going to, I don't have to clone it again, because here, one of the things with Azure Machine Learning is that we have this files. This is actually a file share. This is part of the workspace. So all of the compute instances that you have in your workspace can actually read and write these files. So since I already cloned the repo, I'm not going to have to clone it again. But assuming I was actually starting this from the first time, and I have, if you go to the repo and go through all the steps one by one, I'm trying to explain this also with the documentation. Hopefully the articles with the code in the repo will give you the full picture.
That's cool.
So what you're going to do here is I've cloned the repo, but then since this is a new instance over here, this is what I need to do. I need to change directory, go to using Azure Machine Learning. I need to go to CD01, prepare. And the first thing I'm going to do is I need to install a couple of different packages on this compute instance so that I can actually use R with VS Code. So
Just to be clear, this is to make the new compute instance have all the R goodness that it needs to run.
Right. So the compute instances, when you start compute instances, R is already installed. Yeah, R is already installed, and it has a lot of different packages. And I can show you. If I type in R, you see I have an R session over here. And if I type in library, which lists all of the pre-installed libraries, I have a bunch of libraries already pre-installed. A lot of the most popular ones, including the tidyverse and ggplot. There's some machine learning libraries over here. There's some statistical libraries. So this comes already out of the box with a lot of libraries. The other library that you need, and it's already here, is Reticulate, which allows you to use Python. You can use Python through R.
Right.
So, and that's important today because since the SDK we have, so there's two things I want to talk about. There's the SDK and there's a CLI, the V2. The SDK is Python. But you can, again, even though there's no native R SDK, you can use Reticulate with R to do any sort of SDK things, or the CLI, which is what I'm going to show today. But regardless, to be able to use R with VS Code in an interactive way, there are two additional libraries that you need to install, which are not pre-installed.
Okay, that makes sense.
Okay, so, and that's here in this script. If you click on the script, you see here I'm installing language server and HTTP GD. Now, how do I install this on a new machine? It's as easy as clicking on the dots, run script in term. Make sure that the compute instance you're running is the right one if you have multiple. Run script. I trust the contents of this file. This will take, this can take a couple of minutes. Sometimes it takes longer. Sometimes it's faster depending on, I guess, CRAN. Right. But I'm going to go back to once all of this is done, right? Well, let's see. It'll take about 3 minutes. So I don't want to spend time looking at this. So what you end up going is after it's done, I can go here where this one's like, AI show demo CI, and I can click on, so a couple of things. I'm installing the libraries, the R libraries that allow VS Code to work with R. There is an VS Code extension that you also need to install, but that will happen. Actually, let's see if this is done. No, it's not done yet. But the way, so you install the R libraries first, you need those. Then I'm going to start VS Code. Once that's done, if you click here on VS Code, this is going to open. It's going to, well, first of all, you need Virtual Studio Code installed on your local machine.
Right.
Okay, so that's a prereq. But once that's done, what you're going to see is, I'm switching over to VS Code. So you click on this, it's going to open VS Code and it's going to create that remote connection. So I'm showing you again, the turkey out of the oven over here.
So wait, hold on. So this is actually running on that compute instance you created. And in order to get this to work, you had to install a couple of packages on the compute instance and then a extension on Visual Studio Code, which I'm guessing is already installed. And now you're literally
No,
running.
the extension is not. That's why I want to try to show this with like a brand new one.
Oh, I see. I see.
Okay, but I don't think I'll be able to because I have to create another window and sort of so forth. But what happens is when you first open VS Code, what you're seeing here. So this is what you're seeing here is my local. It's VS Code running on my machine, but it's connected to a remote machine. And as you see, if I point down here, it says AI show demo CI. That's the compute instance I'm connected to.
That's cool.
And then because I've already done this, you're going to get a notification. You're going to see a couple of notifications the first time you do this. It's going to say it's installing the VS Code remote server on the remote machine, right on the CI, on the compute instance. It's creating the SSH connection. And then the last thing is when the first time you're going to open here, I'm jumping around here for a second, but the whole idea here is to be able to do this, to go open up a piece of R code, right? So when you open up that R code, you're going to get a notification on the bottom right that says, do you want to install the R extension for VS Code? And you have to say yes.
That makes sense.
So once you have all of these three things installed, you're able to do this, which I'm going to show you right now. Now, again, I'm skipping around like the way my repo is structured, 1, 2, 3, 4, 5, 6, 7 through 9. It's just sort of a logical step. But okay, so we've done 01. I've showed you how to do that. You have to basically run this bash script, then you have to connect to it, and that's already done. The second thing is, and again, I already have this done, but I have a file here that I'm going to upload to Azure Machine Learning and register that as a data asset.
Cool.
Again, why? Because I'm going to show you how to read that file into your interactive R session. What I'm going to show you in the interactive session is different than running an R job, because when you run an R job, whatever file you specify gets mounted locally. That's not the case for an interactive session. So to do that, we're going to use pandas with Reticulate to read it in. So we'll get to that. But the whole point is, before I can do that, and I'm going to switch back to Azure Machine Learning, what I've already done here is I've registered a data asset. So if you go to the data tab, you see I already have this registered data asset called orange juice sales. And if I click on it, right, I can actually explore the data. Again, I've got, I don't know, 100,000 rows. This is a data set that comes from a paper written back in the 90s around forecasting. Also, it's part of the base package. So I actually extracted this from the base package in R and saved it as a CSV just for example's sake. And we have a couple other examples in our docs that use the same data set. So this is the data. But then when I go back to, when I go back to R or when I go back to VS Code, a couple of things are going to happen. So first things first, I opened up my R. And as you see, this is not a notebook, right? So then the question is, well, how do I actually run code? Well, it's really easy. Like most IDEs, you can actually select a piece of code. And in this case, I'm going to press Control Enter. There we go. And what you see is when I do the selection and then I press Command Enter, that's on a Mac. On Windows, I'm guessing it's Control Enter. I don't know what the defaults for the.
No, that makes sense.
Okay.
It's like,
and then so first of all, I'm loading Reticulate, which is already loaded. As you see before, I actually again, this is a session that I already have stuff installed. So I'm not going to install this again, but I can just do this, install packages, whichever packages I'm going to need. So here I'm going to use my Conda environment. There are a couple of Conda environments on the compute instance. You need to use this one, the one that says SDK v2. That has a couple of packages that you're going to need. The one that we're using today to read in the data is called AzureML FS spec. So what that allows you to do is allows you to read tabular data from a registered data asset. If you were using Python, it reads it directly into pandas, but here we're reading it into an R data frame. So essentially using pandas as a bridge to come into a data frame. So to do that, right, you actually need to get the URL of that data asset. So I'm going to switch back to data, and if I go here, the URL is this one here. It's data store URI. So you can either get it from the UI, which is this one over here, and click to copy, or in my case, I'm actually showing you how to do this programmatically using the actual Python SDK. So we're going to run these two pieces of code, right? So this is the lines. Okay. So we're going to run these two pieces of code. This is just the Python instruction, and then line 27 is the execution. So I'm just going to click on both of these. I'm going to run them. Again, as you see, right, the code gets sent from my editor down to my running R session. And then if I run line 34, okay, as you see here, URI path is AzureML, blah, blah, blah. It's this really long URI. So I'm just, obviously, the more you can do programmatically, the better. So this is an easy way to do it. Otherwise, you have to hard code it, and you make a mistake, and
nobody wants that.
So this is the thing, right? So once I have my R session running, okay, now I've found the URI. I've loaded reticulate because I need it. But now we're going to load pandas. Okay, so PD. And I'm going to load pandas, and then I'm actually going to read that using the pandas, and then I'm going to use the pipe operator, which is R code, and then janitor, which is an R package that does some data cleaning. I'm just cleaning the names. And if I do head, boom, I have read in a file from a registered data file or a registered data asset directly into my interactive R session.
It's not only cool because you're doing something like here and it's all working, but you're doing it remotely on a machine that's not even anywhere near you.
Correct.
With data that's somewhere else too.
Exactly. Right. The data's not even in this machine.
Yeah.
So,
which is cool.
So this is important, right? Because again, so to get started, this is what you need to do. And then as I say here, from here on, you can really just do anything as you would do with R. So I'm just going to run all this code. So this is a script that I wrote, modified. Again, this is a modified version of another script. It's basically taking the data. It's going to build a couple of time series forecasting models. And the reason I chose time series as opposed to either regression or classification, kind of your traditional ML things, or deep learning, is because forecasting is a task that many customers do. And
sure.
And the thing is, you're not really building you're building a model. It's a time series model. It's not really a machine learning model. I mean, we can argue whether it's machine learning or not. That's not the whole point today.
It's the kind of philosophical discussions that Python and R people have all the time.
Exactly. So I'm just going to run through all of this piece of code. But the cool thing here about one of the packages that I did was that it allows me to do something like this. So I'm going to run this code. I need to load my libraries. I did not load my libraries. Load this. There we go. And do this. And all of this stuff. I won't go through the code. You can check it out in the repo. This does the fit, and also again, this is all time series. But what I am going to do is I'm going to run the code up through here. Okay. One thing I did want to say is in this code, this data set has about 100 different stores and I think 3 different brands. So I'm actually picking a specific store and a specific brand here. I'm subsetting the data to model. And I'm building a model for that one particular scenario. And the reason I'm doing that is because I'm going to show you when you put this into production, how you can pass in those parameters into the job so that you can run this multiple times for different brands and or stores. But the cool thing here is, remember, this is running remotely. So I've created this auto plot. It's just a wraparound ggplot. But when I do forecast plot and I run this line over here, look.
Hey, yo. That's
cool.
cool.
But this, so one of the packages I installed is called HTTPGD. It's a graphics driver, a high-res graphics driver that's running right now on that remote machine, which allows you to display this as a web. Basically, it's a web interface. So I'm seeing this locally, right? As you see, this is a graph. Now, don't judge me for the time series model, please, because that's not the intent today.
Yes.
But the point is, how to do this. So, and then sort of here on down, right? Like you have the way now to read your data well, first of all, to set up your compute instance, which already has the language, R language there, but to set it up so that you can actually work with it with VS Code. So now that we've done that, I'm going to sort of go quickly, right, like step by step into, well, what does it look like when we turn this into a full, like end-to-end?
Right, because there's like that interactive part where you figure stuff out. Once you figure it out, you got to harden it into a script and run it as a job, and then move it all the way to production.
Correct. Exactly
Okay.
correct. So, so if you look at the docs, the articles, one of them talks about how do you here. I'm going to go back over here to the website. So the second article, I'm sorry, the third article says adapt our scripts for production. We try to explain step by step what you need to do. So assuming assume you start from a interactive script that you created. Well, the interactive script is not going to run out of the box in production.
Right.
So you have to do other things. To your point, I want to say hardening, but you have to parameterize it, right? You have to do other things. Now, in this case, because that job script is going to interact with ML Flow, you need to like add some special sauce to it or special code to make it work with ML Flow as well. Okay, so that's all described in the article. I'm going to show you sort of the end results over here. But going back to VS Code, right? So let me give you a quick walkthrough. So we've done step one. We've done step two. I mean, I've already done it. Step three, I have this script. Again, this is my interactive script. So the next part of the process is actually, I'm going to create a custom Docker environment so that my R job runs, right? So remember, interactive, I'm interacting directly with the machine. It's REPL. Write code, read response and that sort of thing. In production, there is no human intervention. So what happens is, or what you need to do is you need to create an actual R container or what we call an R environment. And if we go back to our Azure Machine Learning, what is an environment? It's what's in here. So in environments, you have curated environments, which are environments that we provide, and you can use any of these, or you can create your own custom environment. So with a Docker file, what I've done is I create a Docker, this is for running an R job. So what you see over here in the Docker file is in this container, you have to, first of all, you have to install Python. You have to install the Python ML Flow libraries. One is the ML Flow, and then the AzureML ML Flow, which is our special things that allow you to work with our version of ML Flow. And then the third thing is you need to install these packages, and that's so that your job runs successfully in Azure Machine Learning. And then the last piece here, as looking on line 24 on, is these are all optional packages that I'm going to say optional. These are the packages that your code is going to need to run. So the best thing you can do is, you're not going to install these interactively. You definitely want to install these before you run your job.
Right. So that way it's faster. Instead of having to redo this run, you can create the exact special environment for your Snowflake job that's special and unique.
Right. Exactly. For my R job. So, so I've done that. And then, step number 5 is, okay, now I have my environment now, and I've already, basically modified my code. So in this 05, again, there's a bunch of, in the repo, there's readmes in every step, which explain what's actually happening. But the point is here I'm actually specifying the job run. And then I have the YAML file that I'm going to need, which is this one over here. This is the name of the environment that I created earlier. This is the source. I'm sorry, this is here's my R job. I'm sorry, the R job. The way to read this, and let me close this. I don't need this right now, but the way to read this is the schema. This is the command that actually gets run. So our script, right, which is the executable version of R, the non-interactive, it's running this train.r script, which is over here. And I'm passing in 3 parameters. One is the data file. So this is where I'm passing in my registered data asset. And then I'm passing in brand, and I'm passing in store. Now, the thing with the curly brackets, and this is the same syntax whether you're running R, you're running Python, or basically any. The cool thing about the CLI v2 is that you can, for your command, you can run any executable script. assuming you have the environment set up correctly. So here I'm specifying the parameter brand1 store2. So if I need to run this multiple times, I would just change that. I can create this programmatically.
Cool.
The path right here. So this, my AzureML orange juice. So if I go back to my registered data assets, what am I referring here? I'm referring to this data, this registered data asset over here. Then the environment, this is the actual Docker container, or this is the environment. There's a distinction here. There's actually an environment is a grouping.
built container, right?
Yeah, it's a build container, but it also has a couple other things I'm not really sure how to explain. But but one of them is actually a container that's registered in the container registry. And an environment is not a container registry, but an environment has a container, if that makes sense.
I see. Yeah, that makes sense.
So I have this, and then using the CLI, I have all this done. Essentially, I would go to my let me quit out of here. I don't need to use my interactive R session, so I'm going to go to 05, run job train model, and then here I would do something as easy as I have all my things set up, and I would say AZ. This is AZ.
Oh, I learned a secret. There's a little AzureML button at the top that will just run this file for you. Did you know that? Top right in Visual Studio Code, that button will do this. It will run. Do you see that?
There we go. Oh, I learned something new.
I did a thing.
Yeah. Awesome.
How cool is that? Yeah.
Yeah. Okay. So this is going to run. Now I'm running this job. I'm not running it on a cluster. I'm running, since this is a small job, I'm actually running this job on a container running on the compute instance that I have. Because when you run jobs, you can run them either on a compute instance or in a compute cluster.
I did not know that. So now you taught me some things. This is awesome.
All right. So now, so this is running. And if I go back to my browser, and if I go here to my jobs, you're going to see now this is all lumped under this OJ sales forecasting experiment. But you're going to see that there's multiple runs. Ones I've done before. The one that's running now shows here is finalizing.
So it's almost done.
I'm sorry.
It's almost done. This job.
Yeah, it should be done. Oh yeah, it completed. Perfect. Yay. Okay, so now basically what I ended up doing is I ended up building a model, right? And if I go to my job, you're going to see here all of the things that I created. The first, it tells me what data set I used, right? These are tags that I created. These are the model parameters. These are metrics. These are all things that I logged, right? But what I really want from here is this. I want the model. Yeah, because I logged the model. Yeah, if I go here, I go to logs, right? And then here it is. I have actually logged the model. Now, the model is here in models. This is my model thing. So what I want to do is, unfortunately, you can't programmatically register the model. You can log the model, right? So all of the artifacts for your job, I have my model, I have my output. So that forecasting plot that we saw before, I logged it as part of the job. Cool. I've got all the user logs, and this is cool, right? Because you can actually log your visualizations as well. So then what I'm going to do here is I'm going to go here. And now this is the model that I want to deploy, right? Again, don't judge me on the time series. I'm just saying this is the model that I want to use.
No judge-free zone here.
Okay, so I'm going to go to register model. And so this is an ML flow type model, right? Then I'm going to select here the models directory. And as you can see over here, then I'm going to give it next. I'm going to give it a name. Actually, I already have a model registered, but essentially here I would give it the name, my registered time series model. I'm going to click on next. I'm going to click on register. It might give me an error because I already have one. So if I go back to models, right, I already registered this before. Let me exit out of here. Models. Yeah, so you see, I have actually, the model was registered twice because I registered it at different times. When you register a model with the same name, you still get the lineage. You still have the history of the previous versions.
That's cool.
Okay, so now that I have my model and I have everything done, I'm, just in the interest of time, I'm going to kind of skip through the steps. These are all outlined in the articles, but I'm going to show you at the end of the day what ends up happening, right? I can take this model, right? And then I'm going to create, an endpoint. The endpoint is just a URL, right? Where I'm going to be able to call, or this is an inference model. Mm-hmm. So the one thing I do want to highlight though, is with R particularly is, in order to deploy a model, you have to, first of all, you have to package it in a certain way. That's explained in the article. You have to create it. And then you have to use the plumber package, which is essentially a way of serving R functions as APIs. So with Python, you can do this directly without having to do all the custom code. With R or any other language that you might want to use, you will have to create your own sort of scaffolding.
Got it.
But regardless, nonetheless, at the end of the day, what counts is this. So I have an endpoint. Now the endpoint is just an endpoint. It's just a URL. But then within the endpoint, you have a deployment, which is what actually has the model in and of itself. And once this opens, I'll show you. Right. So here I already have this deployed. Again, if you go step by step in the code, the YAML files are there. There's a couple of ones where you actually have to, well, sorry, let me take a step back. Here I'm using a container image. I needed to build a second image, which was different from the first image, because the first image was to run my job. The second image is to serve my model. So I need a different set of packages. But I still had to build that image. But I built it as a container image directly, not as an environment. And that's just it's just a function of the way the system is, the service is designed.
That's so
cool. Here's my endpoint, and then I can actually, here it is deployed. And now what I can do here is I can actually test this. And if you go to the documentation, and all of this is outlined in these articles, right? If I go back to my articles, and I'm going to click on deploy model, I'm just going to go down here at the end, and I'm going to grab this, which is, I'm going to grab this, which is the JSON that I sent. Boom. So
nice.
So now I passed in. So the way the time series models work, or the one I built, is you build it, you give it the number of periods to forecast. And I gave it 2 periods, and I get, there's a lot more data here. I mean, you can decide what elements of the output in the code. This is actually was done in the code. But here I'm displaying everything that the forecast produces. Now, if I want more, I could do 10 and just do this. And there we go. Now I actually have 10 data points in the future to forecast.
Well, Mark, this is awesome.
Thank you. I'm happy to be able to share this with all of you.
And the cool thing is that, like, you showed us from the beginning, from interactivity all the way to job, to model, to the right environment, all the way to deployment. Dude, thanks so much for spending some time with us, my friend.
I'm happy to. I've been an R user for a long, long time. I'm pretty involved with the community. I teach R, and it's still sort of my go-to default tool. So I'm happy that we can use it. I'm happy that we can show people how to use that language in our platform, because a lot of customers use multiple languages, R including one of them. So again, I'm just really, really happy to be able to help anyone that wants to do more stuff on Azure Machine Learning be successful.
Awesome. Well, thank you so much for your time, my friend. And thank you so much for watching. We're learning all about how to use R with Azure Machine Learning with my friend Mark. Thank you so much for watching, and hopefully we'll see you next time. Take care.